For 9th standard, today we have a derivation. We have a derivation of equations of motion with the help of velocity time graph. So in the previous classes, you have seen equations of motion. There are mainly three equations of motion. And now we are going to derive these equations with the help of velocity time graph. Here we will consider a velocity time graph for a uniformly accelerated motion, provided the initial velocity is not zero. We have an initial velocity. Then based on that graph, we will derive the equations of motion. Okay, so we'll start with the first equation of motion. To derive first equation of motion, we will consider a velocity time graph for a uniformly accelerated motion. So these are the axes of the graph. Here we have time. X-axis we use for time, and y-axis we use for velocity. So we have a time and velocity. We consider a uniformly accelerated motion. So we have got a straight line. The straight line has a starting value. This is the starting value called initial velocity, and the final value we can represent with v. V is our final value. Okay, initial velocity and final velocity. The maximum time taken I just indicate by symbol t. This is the origin of the graph. So using this graph, we are going to derive the first equation of motion. Now we know that for a velocity time graph, if you have velocity time graph for uniformly accelerated motion, when you find the slope of the graph, the slope will provide us what? The slope will provide us the acceleration. So we are going to find the slope. So we know how to find the slope. So slope of the graph. Slope means change in y coordinate. These are the y coordinates. So how will you find change in y coordinate? V minus u divided by corresponding change in x coordinate. For v, what is the y coordinate? X coordinate, it is t. For u, x coordinate is 0. So corresponding change in x coordinate, that is t minus 0. But we know that the slope will provide us the acceleration. So I will write acceleration a is equal to v minus u by t, or when I cross multiply, at is equal to v minus u. Or rearranging, what I will get, v is equal to u plus at. This is known as first equation of motion. This equation relates terms like final velocity, initial velocity, acceleration, and time take. Now we need to see the second and third equation. For finding deriving for second and third equation, we need to find the area below the graph. So area below the graph will be equal to displacement. Okay. So what we'll do? First we will divide the area into two portions. We have a triangular shape and a rectangular shape. For the rectangular, we need to find the area. So we know that total area below graph. Total area below the graph. What does it represent? It represents displacement. It is equal to, we can say, area of triangle. We have a triangle here, plus we have a rectangle also, area of rectangle. So we'll find separately the area of triangle and area of rectangle. First we can find area of the rectangle. We have a length. What is the value of length? This is length, t minus 0. Okay. What is the breadth? This height is breadth. So this is breadth. How will you find breadth? U minus 0. So how will you find area of rectangle? I can give a symbol. Area of rectangle is equal to length into breadth, that is t minus 0. That is the length. And what is breadth? U minus 0. U minus 0. U minus 0 is u. T minus 0 is t. What will you get? You will get u into t. We have got area of the rectangle. Similarly, how will you find area of the triangle? For finding area of triangle, we need the standard equation half dh. Okay, so we are going to find area of triangle. We have half into base length. This is base. What is this length? This length is equal to this length. Both length will have same measurement. What about the area length of the base? T minus 0. So t minus 0. Now I need altitude. This is the altitude. I will give symbol AB. AB is the altitude. So to find the length AB, I know this length. From here to here, what is the length? It is equal to V. Now from here to here, what is the length? U. What will be the remaining length AB? AB is equal to V minus U. Because from origin to this portion, the length is V. From origin to this point, or the length is U. what will be the remaining length? AB, it corresponds to V minus U. So what is the length of the height of the triangle? It is V minus U. So what we have got? But we know that V minus U. What is V minus U from first equation? V minus U equal 80. I can substitute here. I substitute half into T minus 0 is T into V minus U is equal 80. What will you get? Half a T square. UT and half a T square. So what is displacement according to our concept? S is equal to area of triangle, that is half a T square, plus area of a rectangle, that is UT. So we have got second equation, S is equal to UT plus half a T square. Okay, so this is our second equation of motion. Now we move to third equation. To find third equation, what we will do is, we will just shade the area, entire area we will shade. When you shade the entire area, we are getting a trapezium. How will you find the area of a trapezium? Area of trapezium. We know the standard equation, area of trapezium is equal to half into A plus B into H. This is a standard equation. What is H? This length is H. And what are A and B? This length is A and this length is B. Area will be equal to displacement. Okay. So S is equal to half into, what is A plus B? A plus B. This I consider as A. This will be B. What is the value of A? A is equal to U. Plus, what is the value of B? This is the length of B. It is equal to V. U plus V into H. H means this length. 0 to T or T minus 0. I will use T minus 0. So S is equal to half into, I just write V plus U. I can change like this. U plus V equal to V plus U. What is T? T minus 0 is T. What is T? From this equation you can use T is equal to, from this equation T is equal to V minus U by A. I substitute it there. T is equal to V minus U by A. Okay, cross multiply. 2A into S. I cross multiply. 2A is equal to V plus U into V minus U. What is the value? V plus by using identity. V plus U into V minus U is equal to V square minus U square. Or V square is equal to U square plus 2AS. This is our third equation of motion. So, with the help of a velocity time graph for uniformly accelerated motion, we have got first equation of motion V is equal to U plus AT. Second equation of motion V square is equal to UT plus half AT square. And third one V square is equal to U square plus 2AS. Okay, thank you.